Topics. We're going to talk about ellipses today. Now I'm going to give you the definition of an ellipse. The actual definition of an ellipse is a set of all points in a plane such that the sum of the distances from two fixed points is constant. The two fixed points are called the foci of the ellipse. So we got some new words here and things I need to explain. Basically what's going to happen is we're going to take a circle and we're going to stretch it. Okay? And that's what creates an ellipse. So instead of having a center point, okay, which it's going to have one, this thing is centered around the origin. Instead of having a center point like a circle where you just have a radius and you go in every direction and you get the same length and that creates a circle, well, a foci is more, an ellipse is more stretched. And what an ellipse has compared to a circle is, yes, this thing is centered around the origin, but it has these two fixed points called foci. And basically, if you take the distance from here to here and the distance from here to here, it comes out to be a constant number. So I usually explain this as like a ping pong, like a arcade. You know, you got these two fixed points and this guy's going to bounce from here over to here and then back again. And every time it bounces, it creates this ellipse. So we have two things to worry about and have to find, these things called the foci points. They also have what's called a major and minor axis. Okay? And this one is going to be horizontal. You'll see that the ellipse is longer in one direction than it is another. Well, we call that the major axis, and then we call this the minor axis. The foci are always on the major axis. So for this particular ellipse, it's horizontal, okay? It has two vertice points here, two vertice points here, and then the foci are in here, which help create the ellipse. So the foci and the major points are on the same axis, you can see. Whereas the minor axis has a different set of points. So these two will always be together on the major axis. Okay, so this is called a horizontal ellipse. This is our vertical ellipse. Okay, again, you can see that it's longer vertically and the foci are on that major axis. But notice how the vertices are written. The vertices in the major axis are now shifting to the y, and the minor are shifting to the x. And the foci, again, are tied with the major axis. Okay, so break it down kind of easily for you guys. We have what's called, I will refer to these as the horizontal ellipse or vertical ellipse. We want to look at the direction, because if it's horizontal, I automatically know that the major axis will be longer on the x-axis. And if it's a vertical ellipse, the major axis is on the y-axis and should be longer. Okay, now let me give you the formula. Let me give you what this thing looks like in standard form. We are not going to move the ellipse off the origin. We're going to keep the center of this thing around the origin. Okay, so here's what standard form of a horizontal ellipse will look like. Okay, it's much different than the circle. The formula is x squared over a squared plus y squared over b squared equals 1. This is that constant number that is always in every ellipse. It's always equal to 1. I'm not going to prove it to you. It would take too long to prove it to you using the distance formula on how to get that. I'll save that for your college algebra teacher or pre-calc teacher. I don't even know if they prove it. I used to when I did. Okay, so if it's horizontal, you can expect your foci to be plus or minus c or 0. I'm getting to that in a minute. The length of the major axis is going to be 2 times the length of A, which means you're going to have to find the square root of that. The length of the minor axis is 2 times b. Again, we're going to have to find the square root of that to get this guy. So what's this foci and how do I get it? Well, there's a formula. The foci formula is going to be c equals plus or minus a squared minus b squared. The actual formula is, if you ever look it up so you don't get confused, is actually c equals a squared minus b squared. But if we want to get the foci points, we're going to have to take the square root of that. So by just taking the square root of both sides, you'll get the plus or minus whatever c will be. Okay? All right. Let's do a couple. Well, actually, let me give you the vertical. The vertical ellipse. Okay, do you see what happened here in the standard form of the formula? The a and the b didn't move, but the x and the y did. Okay? A will always be your major. It always goes with the variable that's on the major axis. So because y is coming first, I know that this is the major axis. So the foci points have now shifted to 0c because it's going to go with the major axis. Again, the length of the major axis is still going to be 2 times a, square root of that. Minor, 2 times b. And again, the foci is going to be plus or minus a squared minus b squared, square rooted. All right, so we have a lot to find. Seems like it, but it actually isn't as bad as it looks. First of all, I'm going to have you find the coordinates of the center, which I'm going to tell you are 0, 0 anyways, because I'm not moving it. So we're going to assume that the center is 0, 0, and the foci. So we're going to find basically the foci, because I'm going to tell you right now the center is 0, 0. The center could change. You know how I made you move the circle? Well, ellipses can move, but I'm not going to move the ellipse, okay? I'm just going to keep it at the origin. Then we're going to find the coordinates of the major and minor axis. Those will be actually the vertices, okay? Another name for that is let's find the vertices. And you're going to do that by taking the square root of a squared and the square root of b squared. That's how you get those guys. Find the length of the major and minor axis. That's where you're going to do 2a and 2b once we find it, okay? And then we're going to graph the ellipse and its foci points. All right, so here we go. This is our ellipse. And the first thing I'm going to ask you guys is, do you think this is vertical or do you think it's horizontal? Well, this kind of gives it away right here. Because x is first, this guy is going to be horizontal. Okay? The first thing I asked you guys was to find the center. Well, I'm already going to tell you this thing is centered around the origin. And we're going to find the foci. Now remember, the foci is the a squared minus the b squared, which means here's where the foci are going to be. So how do I know how to write them? Well, if you know x is coming first, then it's going to be plus or minus 4, 0. They're going to be inside the major axis. So what is the major axis? Well, here's the major axis. Because 25 is under x, those are the vertices, and here's the minor. Okay, so there's my b. Now what I want to do is actually show you guys what this looks like, so we're going to plot all that. Okay, I think I got a graph. I got a graph ready? Yep. Okay. Make this thing break your knee. Okay, so I'm going to go out 1, 2, 3, 4, 5 on the major. And I'm going to go 5 here. And let's say you just, if you just do the square root of both of those numbers and you plot them, I mean, guys, it's obvious. Look, it's bigger. Oh, gosh, I didn't connect. People, I'm so sorry. Right? This is what my circles look like. They look looked like ellipses the other day. Well, you see where the major axis is? So you can tell here's the major axis. Here's the minor. Now, we said the foci, I told you this is really easy. The foci are plus or minus 4 and 0. Well, the foci are always, and label them, they're always on the major axis. So there it is. That's your ellipse. Okay. Now, I did want to know what the length. Let me switch. Hang on, I'm going here. So the length of the major. Well, I used to just graph it for my kids, and we know A is 5, so it's 10 units. You basically can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 units. You can even count that it's 10 units. Okay? Length of the minor. Is 2 times 3, which is 6 units. Okay, and I think we've answered everything. We drew it, we plotted the foci, we did the length of the major axis and the length of the minor axis. That's pretty much it, everybody. It's pretty easy. Okay, that's a horizontal one. Now let's do this one. Okay. Alrighty. See who's first? The Y is first. So that means that this is your major. Okay, here's your major axis. So here's what's happening here. First thing we're going to do is find the foci. And that's going to be, C equals plus or minus 36 minus 4. C is going to equal plus or minus the square root of 32. Okay, which we'll convert in a second. Now, a lot of teachers want you guys to do this, which I would appreciate. If we're simplifying, it's 4 square root of 2. But we're not, and then we got to figure out how to plot that. So how do you write the foci? Well, since the major axis is y, it's going to be 0 plus or minus the simplified version of 4 square root of 2. Okay? So that's why I want my foci written. We're going to take out a calculator to figure that out. Okay? So don't worry about that. Actually, I can probably estimate that guy. All right. The next thing we want to do is find the vertices. Okay? Okay, so the major axis is on the y. So we're going to do the square root of b. Well, actually, it's easy just to do the square root of that. That's going to be plus or minus 6. But remember, it's on the y. And then the minor, I'm running into c, which this time is on the x-axis, is the square root of 4. And again, a lot of this comes out just from the picture. So if you go, so what we're going to do is, even if you just graph it the way you see it, you'll see the major axis come out. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. See? I mean, you can kind of tell just by the vertices where the major axis is. Okay? Now, remember the foci are inside. So you take out a calculator and you find out that the square root of 32 isn't quite 6 and it's greater than 5, right? So, well, that's the cool thing about this. We know it's not 6, it's less than, and it's just greater than 5. So most of us teachers are okay with you putting it here, but just between 5 and 6. And there's your ellipse drawn. Okay, the length of the major is going to be 2 times your A value, or whatever 36 was. Square root of 36 was 6. It's 12 units. And the minor is that 2 times, what was it, 2? Which is 4 units. Again, it's kind of a no-brainer. You can just count 1, 2, 3, 4 and count 12. Okay? You almost don't have to really even need to use a formula except for the foci, because you can always count the major axis and minor axis. Okay. Write the equation of the given ellipse. All I want is the equation. Okay. This is easy. Where is it longer? Well, this is on 3, this is on 2. So that means the x-axis is my major. Okay, it's on 3. So you're going to do 3 squared. This is on 2, so you're going to do 2 squared. X squared over 9 plus y squared over 4 equals 1. It's almost insanely easy as the circle. I can do those all day long. Okay? No foci, just want the equation. Okay. All right, so wrapping it up, here's all your nifty little formulas. Okay? Here's what we're going to do. Okay? We are going to write the ellipse given the following information. Okay? Write the equation of ellipse given the following information. Here's what I know. Endpoints of the major axis are positive and negative 7, 0, and the endpoints of the minor. Now this is totally up to you. Remember, I'm going to keep these centered around the origin, so I'm not going to be moving them. Sometimes what I used to tell my kids is if you want to, just plot it. You know, if you're really having trouble, go 1, 2, 3, 4, 5, 6, 7. Go 7 in this direction. So there you go, 7. Then you go, okay, 1, 2, 3, 4, 5, 6, 7. And then you go 5 the other way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you can kind of see, even though I'm not using graph paper. Actually, all right, don't laugh at me. But you can tell this is the major axis. Okay? So, oh, I just did that wrong. Oh, Miss Mitchell. Now, those of you who've had me before, no, I do that all the time. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Sorry, I went the other way. There we go. Okay, those of you who had me before, you know I do that all the time. So you can kind of see it's a little longer on the x. So since it's x squared, a is going to be 7. This is going to be 5. And there's your equation. But please tell me that's 49 plus y squared over 25 equals 1. Okay? All right, any questions on that part? Okay, now, okay, next set of information. Still centered at 0, 0. The major axis is 20 units long, and the minor axis is 8 units long. Okay. Okay, what did I think? I forgot to give you some important information on this one, because it could be either way. What did I forget to tell you? Oh, I should probably tell you the foci points. Would that help? Hang on. Oh, I left out a major part, I guess, because because you don't know if it's vertical or horizontal. What part did I forget to tell you guys? Should I tell you the foci? Hang on, let me think about that one for a second. I know what it is. Okay, yeah, here's what you guys need. Okay, I'm going to give you the foci points. Oh, maybe not. Hang on. Okay, I'm going to change this to 16. All right, let's do this. Let's make the major axis 20 units long, and the minor axis is 16 units long, which means the foci points are plus or minus 6 and 0. Okay, that's going to help you. All right, so if I tell you the foci points are 6 and 0, then now you know that the major axis is going to be horizontal, because the foci are always inside. Now, you're going to take 20 and divide that by 2 to get 10. And you're going to take 16 and divide that by 2 and get 8. Because of the way the foci are written, that's going to tell you that it's x squared. And remember, the length of the major is always twice what A is. So that means B is 8 squared. So what's our ellipse? It's x squared over 100 plus y squared over 64 equals 1. And if I subtract those two, I'll get 36, and the square root of 36 is 6, so it works. Okay? Yeah, I forgot to give you that. That's kind of important. Okay. Last one. The endpoints of the major axis are 6, and the foci is 32. Okay, so here's what we have to do with this one to work backwards. Okay? Okay, so to work backwards from this one, what we're going to do, did I just do, hang on y'all. Yep. Oh, wait a minute. Yep. Okay, never mind, just checking. All right, so for the next one, here's what we got to do. Okay, so the endpoints of the major axis and the foci make sense because they're both on the y-axis. Okay, so that means the y squared is going to come first. And we can kind of do a lot here since we know this is y. This has to be 36. But I don't know what my b squared is. But I know what c is. So this time we have to work backwards from the foci formula. Okay? And here's how we're going to do that. We know that 32 is the length of the foci. And now remember, it's a squared minus b squared. So this is going to be 36 minus whatever b squared is. So if I subtract 36, yeah, be careful, I get negative 4. But remember, this is negative b squared. If you divide by negative 1, you found the b, or b squared. You get it real quick. So that's what I'm going to assert up here. Since I now know from working backwards in the foci formula, don't take the square root. Remember, it's going to be whatever's under there. So that means this has to be 4, which makes sense. 36 minus 4 is going to be the square root of 32. So it works. Okay, everybody, I think that is it. That is your your ellipse set at the origin. Okay, underclassmen, that's all for you.